Hi, welcome to another edition of Antique Radio Archaeology. Today we're going to be doing the restoration of a 1927 Chelsea Model 128, better known as the Chelsea Truphonic 6. Now, this particular radio I've been wanting to get to for a very long time. It's one of the most beautiful radios that I think they've made, and I'm really looking forward to this. Now, this particular restoration took me about 2 months, so there's a lot of ground to cover, and unfortunately I don't think I can justify doing just one video, so I'm going to do this in two parts. This first part, what I'd like to do is talk a little bit about the history. We're going to disassemble everything. I'm going to restore the chassis itself, and then we're going to work on the inductor block, which I'll get into as this video goes along. So let's go ahead and get started. The Chelsea Model 128 looks identical to the deluxe version of the Chelsea Model 125, but the similarities are actually minor in the evolution of this new radio. Chelsea introduced their more technologically advanced 6-tube model in October of 1926 through magazine advertisements that called it the 1927 Chelsea Truphonic 6 radio receiver. While the radio looks similar, the appearance actually hides an interesting problem that it actually resolves. I'll get into that in just a little bit. So it's a dramatic change from earlier models. There are more wires that include 2 C battery voltages and an additional B plus voltage. The ability to use a 171 or 371 power tube in the third stage of amplification is the reason for the additional wiring. And as you can see here, this accommodates an extra tube on a plate that was added, and we'll talk about that in just a few minutes. But the most dramatic change is the quality of the sound, and it's called Truphonic. Now, Truphonic is a word that identifies a type of amplification that was discovered by Dr. H.P. Donnelly. Dr. Donnelly worked for Connecticut Telephone and Electric Company, and this man has held over 50 patents, and he's known for his sodium detector, which he eventually started his own company with. Now, he did not patent the amp or the trademark the name Truphonic, which he should have, but it was actually used by quite a few companies over the next few months and the next couple of years. So truphonic sound is another term for inductive coupling. There's a reason why this is important. So to better understand, let's talk a little bit about magnetic coupling or transformers. The disadvantages of transformers at that time is that they could only pass between 300 and 3000 hertz. Now, as you know, human hearing is between 20 and 20,000 hertz. So a large part of the audio spectrum just really wasn't getting passed. So early operators realized this, and they preferred using headphones on the detector stage over speakers, which sounded tinny and unnatural. So there are a couple of reasons why this happens. First of all, the limitation of magnetic coupling, which I just described. The second being the limitation of tube operation by trying to keep the grid negative, which would very easily build up a charge if driven too hard. So between those problems, engineers had an issue trying to add additional stages of amplification. The reason they didn't is because noise and distortion would become too great on that third stage, and as such they just didn't do it. So most radios at this time would have just 2 stages of amplification. Now, the Truphonic amplification eliminates those problems. Instead of transformers, choke coils were used, and even though they were in the figure-8 lamination frame, they looked just like transformers. They were not magnetically coupled. Grid charges were bled off by using the coils as impedance between the stages, so this provided an almost direct short for DC current buildup on the grid, allowing it to be immediately removed. You can see that right here on the Donnelly amplifier section of the 128. This allowed the entire audio spectrum to be passed and a higher amplification by the tube. The trade-off was that transformers also amplified. Losing them lost some of the amplification in this process, but the Donnelly method allowed for additional stages to be added So by adding a third stage, the same level was achieved. The Chelsea Trufonic 6 actually uses standard inductive coupling on the first two stages of amplification, but they use the Donnelly Trufonic amplification in the final stage. The Trufonic amplification findings were first published in mid-1926, but Chelsea managed to actually get their version of its production by the end of the year, which is something that's really astounding if you think about it. We're talking just a few months they went from basically theory to actual production model. So in order to do this, the case and the chassis from a Super 5 were actually used. And this is a Super 5 here to show you the comparison. The chassis was actually modified by cutting out the center tubes and replacing it with two tubes mounted on a plate. This raised plate was actually dampened with felt, which was another advantage as sound vibration didn't cause noise in the detector stage. So by adding a tube to the space reserved for the transformers, they were able to get the 6 tubes required for the Donnelly amplifier. Now in the 128, Chelsea transformers were used as choke coils by clipping the leads off the primaries of existing Chelsea Super 5 transformers and using the secondaries as the coils. And as you can see, the resemblance to the Donnelly coils is actually pretty amazing. So I actually have 3 Trufonic 6 receivers. Now, I'm going to try and get 2 of them operational, but this is the one that we're going to be working on today. Now, if you want to see something interesting, if you look on radiomuseum.org, you will see that this is the one that's actually pictured there. So, let's see what we can do with it. Okay, so here's our Super 6. What we're dealing with is a few issues. My biggest concern is this right here. This is obviously warped very bad. I don't see an easy way of fixing that. So what I'm going to do, I do have 2 other Super 6s. I'm going to go ahead and replace that with one that isn't warped. But this is the one we're concentrating on, so I will replace that top. Other than that, it is kind of scratched up. The face is in really good shape, and that's the reason I'm using this one for this restoration. What I do like is there are some tags on the wires, so we can definitely tell what we've got here. And I'm going to try and hold on to this cord. I don't usually do that, but this one's actually pretty pliable and seems to be in relatively good shape, so I might be able to salvage that. Now inside, this here was at one time shiny. So I'm going to probably repaint this, and I'm missing a couple of placards. There's one here for the antenna. And actually I do have that placard, but I'm going to recreate it because the old placard is brittle and basically is falling apart. There's one that goes on this side that has what all the wires are, and that one is missing. So I do know somebody that has one, and I'm going to go ahead and recreate that one as well. So that should take care of that. The rest of it is determining whether or not this thing's operational. I do have a window here that's slid off. Hopefully I can clean those up and reuse them. If not, I'll replace them. But the dials seem to be in pretty good shape. But I need to go ahead and pull this apart to see what we're looking at on the inside. So let me go ahead and get started on that. So afraid I'm going to break something here. Okay. Finally. Wow. That's something else. I gotta look at that. That's way too tight. Okay, so after looking at this, I've decided that I'm definitely going to replace this case. What has happened is this thing somehow is bowed in. It's rubbing really tightly against the sides of the faceplate, and I've got 3 of these radios. 2 of them I'm going to restore. One of them is just going to be a hanger queen. This can go with the hanger queen. I think the other 2 cases are in better shape, so that pretty much, I think that's going to settle that argument. So this is going away. I'm going to go ahead and grab another one and pull the case off of it. So go ahead and do that. Okay, so this is the case I'm going to use. I'm going to go ahead and get this one prepped and cleaned up. So get started on that. Those windows are just little pieces of plastic. These are just pressed in there. That's amazing. There, now all I got left is a wood panel. So I can go ahead and get started on that. So I figured out a little trick. If you cut these two short here, the rest of this as is, what you can do is slide that out, and then that whole thing comes out. So that's the way to do that if you ever have to. But you definitely need to cut two of those off. I figured that out because one of the other radios had that and had been worked on, so I guess they were smarter than me on that one. Okay, so as you can see on my dials, I do have some discoloration, and that's actually due to the not the varnish, but the shellac that they used. And shellac comes off with alcohol. Unfortunately, I need to be real careful. I don't want to erase any numbers. So I'm going to go ahead and see if I can't clean this stuff up. What a difference already. Doesn't seem to be affecting the numbers. There you can see the comparison. There you go, just like new. Okay, I have a little bit of an issue here. This faceplate will not fit in the front of the cabinet due to the fact that the wood is slightly bowed on it, so I got to remove just a little bit of material off the edges here. I hate doing that, but you know, that's the only way it's going to fit right. You got to do what you got to do. So this is the fit issue I was referring to when it came to the front plate. What was happening is I tried to put the front plate on here and it would not go. It was stuck. I could slide it about this far in and it was just jammed. What has happened is these two sides have bowed slightly, and you can't see it real well with the camera, but if you get kind of along the line here, you can see where there's a slight bowing inward on both sides, and it's even more dramatic down here than it is up here. So it isn't noticeable, but it's noticeable when you try to put the front plate back on. So that's why I sanded down those two edges. And I only took a very little bit off of it, not a lot. I didn't need to, but now it fits just fine. So these are my dial windows, and if you remember, they go behind there, and as you can see, they're not very clear. But if you happen to have seen my video on the Chelsea condenser, you know what this material here is. And this one actually happens to be cut the same width. So I'm going to go ahead and just use this piece. This is just scrap. I'm going to use this to make new dial windows. So it should be pretty simple. I'm just going to lay this on here. Mark it. There we have it. New window. Pretty simple. So this has been my biggest issue with this radio, and it seems to be a big issue with all the Truphonic 6s, and it is called a capacitive inductive coupling block. And what this is you have a series of capacitors and inductors that couple the different stages of amplification. So once I leave the detector, I'm going to hit C1, L4, and C2 before I couple onto the grid of V4. C1 is here, L4 is here, C2 is here, taped to the inductor. Now, when I leave V4, I'm going to hit L5, which is right here, and C3, which is also taped right here. You can barely see that one. And it goes on to the grid of V5. And then once it leaves V5, it does an interesting little twist. It goes to L6, C4, which is between these two, buried underneath that cardboard, and L7. So the biggest issue that I'm seeing with these is L4 seems to be open on pretty much every single Truphonic Super 6 that I've come across. I have 3 of them. I know of a guy in Canada that has one who's working on one right now, and all of us have the same problem. Luckily, I have a bunch of old transformer cores that for some reason I didn't throw them away, and I'm glad I didn't, because the secondary on this one is shot, but the primary is still good. So I can use this to replace that coil there, which is what I'm going to do here next. And also, while I'm at it, I believe these are paper condensers here and down in here, paper and wax. So I'm going to go ahead and get rid of those. I've got some replacements here that'll work just fine. Now, I did check all the different capacitances and resistances of all the radios that I've got, and what I've come up with is I should be reading about 0.25 microfarads on C4, which is the one that's buried in here, and that's what I got here. And then I should read 0.0002 on this one right here, which is what I've got here. So I'm going to go ahead and replace those two capacitors while I'm at it. This one I believe is mica, so I'm going to leave this one alone. And this one here is fine. So I'm going to try and leave that soldered on here. As you can see, there's nothing on the back here. There you can see the capacitor that's between these two coils right back there. Alright, so there's that pack. This one should come off pretty easy. There we go. I'm going to go ahead and remove these so I can polish these a little bit. Get them cleaned up. I don't like that they used electrical tape there. Okay, there you can see that capacitor. It's definitely a wax and paper capacitor. I'm glad I'm replacing that with this one here. So this is my bad one. It's reading in the mega ohms. This is my good one, reading 5.9K. I know this side's bad. It's reading in the megs. Alright, what I want to do, plus I can see the inside coil here. Go ahead and snip those two, I don't need them. So now I've got a coil here, extension wire here. Okay. Well, this really kind of sucks. I just finished doing this and realized I didn't turn the camera on. So basically all I did was I heat shrunk the wire down here. Now I did solder this one at the top to this capacitor, and I soldered another wire onto that capacitor, a different one, and I put one loop of this is cloth covered wrapping tape. It's not the same as standard electrical tape. It's what they used back in the 1920s, really. So I'm just trying to keep to the same theme. But anyway, this side is done. Now I need to get this capacitor, pretty much do the same thing with this capacitor here. I'll go ahead and reassemble this. Goes up, this one goes down. There we go. All right. All right, that takes care of that. Okay. Just exposed wire, that's all. Okay. What I'm going to do is replace that with heat shrink. There we go. All right. All right. All right. Okay. So. Okay, very briefly, what I wanted to do is show you what I did here. This is the old wiring harness. I went ahead and I actually cut the old sheathing off of it, which took me a while, but then as I was doing that, what I did was I took all these wires and I wrapped them very tightly together, and I wrapped electrical tape around it. And what this is here is a long shoelace, a very large shoelace, brown. And I cut the tips off and slid it over the wires all the way down, and I just basically kept working it down, working it down, working it down all the way, and basically replace the outer sheathing here with this, which turned out really nice. It was very tight. It took me quite a while, but I think it turned out just perfect. So that's how I did that, and I'm going to do a video on how to do this at a later date, but I just wanted to just kind of let you know what I did. And I attached the other end to the coil block, so we're all ready to go for reassembly. So this concludes part 1 of this video series. Now in part 2, what I'd like to do is go ahead and continue the reassembly of the radio. We're going to actually get everything together and test it out using the 4 different battery configurations. Now this is really important because the final configuration is going to involve replacing the last tube in the amplifier with a 071A tube. So I'm really looking forward to seeing how that works out. I hope you enjoyed this video today, and if you want to see more, definitely stick around for part 2, which will be coming out shortly.